So given a sphere with radius r, we want to derive the formula for the volume of the sphere in terms of its radius, or the function v of r. And I am going to do this derivation by using calculus. So just like explained in my cone video, a sphere is radially symmetric from all sides from any axis that runs through the center of the sphere. In other words, if we took a semicircle with radius r, place an axis along the straight edge, called the central axis, and revolve the semicircle a full 360 degrees about the central axis, we would get our sphere with radius r. And by analyzing the sphere in this way, we see that it falls under the profile of a solid of revolution, or any solid created by revolving a 2D shape about any axis. And further, seeing that any cross-section perpendicular to the central axis is a solid disk, we can use the disk method to find its volume. So we proceed. So we draw out our xy graph. Then we draw out a semicircle just so its center is at the origin, and it extends from x equals negative r all the way to x equals r. And the reason we do this is so the equation for f of x isn't too messy, because by placing the semicircle with the center at the origin, it ends up coinciding with the circle that has a center at the origin also. And since you all know that the equation of a circle is x minus h squared plus y minus k squared equals r squared, where r is the radius of the circle, and where hk is the center point, setting the origin 0, 0 as a center point gives h equals 0 and k equals 0, drastically reducing our equation down to x squared plus y squared equals r squared, and easing the workload. And if we solve for y, we get y equal plus or minus the radical of r squared minus x squared. However, we are only concerned for the positive side, as that is a function of our semicircle, and that will be the function to be revolved. So we let f of x just equal radical r squared minus x squared. Now that we have set up our graph and equation, we are ready to start with our method. But before I jump to the disk method, as a quick side help for those of you who struggle understanding this method, you know that if we take an instantaneous strip of length f of x and width dx having an instantaneous area dA, where dA equals f of x dx, and integrate from x equals negative r all the way to x equals r, we will simply just get the area under the curve f of x, or the area of the semicircle. But now in the disk method, instead of an instantaneous rectangular strip, we now take an instantaneous cylindrical disk of radius f of x and height dx, with its instantaneous volume dv equal to pi times f of x squared times dx, because the volume of a cylinder is pi times height times radius squared. And integrating this from negative r to r, we will then get the volume of our sphere. And now that we have our integral, we plug in for f of x, and we get the volume equal to the integral from negative r to r of pi times the radical r squared minus x squared squared dx. Seeing that the square and the radical cancel, and that we can pull the constant pi out, we then get the following. And now we integrate the integral, and we get the quantity r squared x minus x cubed over 3 from r to negative r. Plugging in our limits, we then get the following. Distributing the negative in r squared times negative r and negative times the quantity negative r cubed over 3, and seeing that the quantity negative r cubed is simply just negative r cubed, we then get volume equal to pi times the quantity r cubed minus r cubed over 3 minus negative r cubed plus negative r cubed over 3. And seeing that r cubed minus negative r cubed is 2r cubed, and that negative r cubed over 3 minus r cubed over 3 is negative 2r cubed over 3, we then get the following. And finally, we do our subtraction, and we ultimately end up with 4 over 3 times pi times r cubed, and this here is a volume of a sphere. So there you have it, the derivation for the volume of a sphere using calculus. I really hope this video helps out, because trust me, the proof doesn't get any simpler than this. If you like what you learn, make sure to hit the subscribe button as well as the like button. As always, thanks for watching.